Alright, looks like we have another question here. This is question 49. Finding the length of a guy wire. So the problem states the height of a radio tower is 500 feet. So let's start with that. Okay. Let me get one of these shapes here. Height is 500 feet. And we'll label that. And the ground on one side of the tower slopes upward at an angle of 10 degrees. So here we have this 90-degree angle here, but then the ground slopes up, and we're going to say that this is 10 degrees. Oop. 10 degrees. So, part A says, how long should a guy wire be if it's to connect to the top of the tower, which is up here, and be secured at a point on the slope side 100 feet from the base of the tower? So, excuse me. So we have to figure out connect to the top of the tower and be secured at a point on the slope side 100 feet from the base of the tower. So has to come to sorry, they're not straight. Here we go. And right in here is 100 feet. So the wire's got to get to at least this far from the top on this slope. So now what we have to do is figure out. So you know what? I'm going to move this 500 feet here because it looks like it's the wire, but it's not. So we're going to here. If we can grab it. There we go. Perfect. So we have 500 feet here and 100 feet here. But we need to know what this side is. So since this was a 90-degree angle and 10 degrees is already taken up, this leaves us with 80 degrees. So we'll state that 80 degrees. So now we have side, angle, side. And if we go back to SAS trig here, side, angle, side, we'll come upon the law of cosines. So let's bring these two together. So we have angle, we'll say this is angle A, and we'll define it as capital A. And we're trying to find lowercase a over here. We'll say this is B on this end. So then 500 feet over here is going to be lowercase b. And we'll have C up here. And opposite of that is the 100 feet. It's getting a little crowded now. and that's going to be 100 feet. So let's write out what we have. So angle A is equal to 80 degrees. Our side B is 500 feet. And our side C equal to 100 feet. So now we have all our requirements. Now we must apply the law of cosines. And I'm going to copy this and paste in this notepad here. And these are all squared. Alright, so since we need to find side A, let's start plugging in the numbers. 500 squared plus 100 squared minus 2 times 500 times 100, and we need the cosine of A, which is, oh, sorry about that, cosine of A, which is 80 degrees. Right, and now we're just going to use algebra mathematics. So 500 squared, it's this big number, plus 100 squared, which is 10,000, minus 2, and let's see, 5, 1, 2, 3, 4, and cosine of 80. Which is this big number. Now we're to continue till we get to the A squared. 2502. Sorry about that. I'm just gonna type the whole thing over again. 250123 plus 10,000. It's gonna be 260,000 minus, and let's see, hopefully I have a history. Oh. Let's see. Alright, so we're going to multiply the cosine times 50,000, and we're going to multiply that by 2. So just multiplied all this out and came up with this big number here. And now we're going to subtract 260,000 minus the number, and we come up with this number. But since we're looking just for A, we need to square root both sides. So A is going to equal to the square root of this number, which will be 492.5 feet. And that's how long the wire has to be. So we'll say this is 492.58 feet to get at least 100 feet. And to confirm that we got the right answer, we have the answers here. So for question 49A, 49a, 492.6, and if we rounded it, it would be 492.6. So we can see that our answer is correct. For part B, how long should a second guy wire be if it is to connect to the middle of the tower? So, keyword there is the middle. So right here. And let me draw another line. Because we're no longer on the slope. So how long should a second guide wire be if it's to connect to the middle of the tower right here and be secured at a position 100 feet from the base on the flat side? So, sorry about that. Oh man, that's an ugly triangle. So, we have 100 feet away from the base. So now we have a 90-degree triangle here. As you can see, there's no slope. We have 90 degrees. So we could use the law of cosines on this side, but not just use the Pythagorean theorem since we have two sides already, and it's a 90-degree triangle. So let's apply the Pythagorean theorem, which is a squared plus b squared is equal to c squared. So going back to my notepad here, a squared plus b squared is equal to c squared. We'll say that so we'll say that 100 feet is a squared. And actually, you know what? Let's go based off the values that we've already given. So this is a. On the other side, opposite side would be little case a, right? And then let's define angle B, and little case b be the height here, and then c over here, and then this would be little c. So lowercase a, we don't have it, so we say a squared, and we can put it like this. Let's do it this way. And then b is going to be the 500 squared, and then we have c, which is 100 feet. So let's get our numbers to the right and letters to the left. And just to make sure I'm getting this right, because I want to say I got the Pythagorean down, but we'll see. A squared plus b squared, you see. Alright, good. So yeah, a squared plus b squared equals c squared. Alright, here we go. So we want unknowns on the left, numbers on the right. Got a squared is equal to 500 squared, sorry, negative 500, and a positive 100 squared. then we just calculate using math. So 500 negative negative 500 squared is equal to 250,000 plus 100 squared, which is 10,000, and then we'll add them up. So plus 250,000 is equal to 260,000. So a squared, bam. So now I have to take the square root of both sides to get rid of this square root and just have side a. So a is equal to the square root of our problem here, which is going to be 509.9. And that does not seem to be the answer. So let's see where we went wrong here. Yes. So I messed up at around the halfway mark, right? So this is why we clearly define our picture the right measurements. So don't forget to label your pictures. So let's go back in here, and I'm keeping this in because I want you to see the process that I go through, so that you can learn from it, and it's a trial for everyone. So let's go back and let's figure out our answer again, now that we have correct inputs here. So we have 250 squared, but it's a negative, right? So now we get this number, which is a very different number. And we'll add this 62,500 to our 10,000, which will give us, move this over here so it doesn't disappear, 72500. And now we square root this number, which will give us 269.3. So we can say that side A will equal to 269.3 feet. So that's how long the wire has to be. And if we check our answer key here, it states that it's 269.3 feet, and that's what we have. Alright, well, I hope you learned something, and I guess I'll help you along with the next problem when it comes.